Delmy says, hi. Today we have here questions which involve simultaneous equation. But it's not the usual simultaneous equation that we've been doing, because here the variables that we have here do not have a coefficient that we need to eliminate. Meaning, our focus to get the answers here shouldn't be the coefficient. The emphasis wouldn't be on coefficient, because the variable x and the x here, they have one thing which is differentiating them both, which is the exponent. So here we could say that the exponent for this x is power 1, is 1, and this is half. So in this case, in solving them simultaneously, we wouldn't have to add the two equations or subtract the two equations. Otherwise, we'll be doing a merry-go-round. Okay, so what we have to do is to either multiply the two equations or we divide. Good. So what I will do is to divide the two equations. So I will make this equation 1 and make this equation 2. So we divide equation 1 by 2. I always use the greater value, okay, on the smaller value. So that will be, implies that x minus y equals 95 on the root of x plus the root of y, which is on 19. Okay, now when we have this type of equation, what comes to our mind first is that it looks like a set. So yeah, perfect, that is set. So what you have to do is to rationalize this we have here. So we're having multiply here and here by the set down, so by the conjugate of the denominator. So we have x minus y times the root of x minus the root of y. Okay, so the same thing we do down here for the downside. So we have the root of x plus the root of y, okay, times the root of x minus the root of y equals, so this should give us a 5. Okay, so multiply this, but remember earlier on that the x minus y has a value of 95. Okay, so anyway, so we may decide to hold on to that first. Okay, so we simplify this downwards here. When you simplify this, you get difference of two squares. So x root of x times the root of x, okay, which will be root of x squared. Okay, so that will give us x. So let's maintain the numerator. So we have x minus y root of x minus the root of y all on. So we do the same thing here. So we have this times this, since they are conjugate, so we have difference of two square. So what you have to do is just multiply this to this. Okay, the first term with the first term here. So we have root of x times root of x minus the root of y times root of y, so y equals 5. So that means that we'll be having this and this will clear off. So we'll be having the root of x minus the root of y. That does make sense. Perfect. So we'll be having this should be equals to, it implies that you're having the root of x minus the root of y equals 5. So because this and this will clear off, so we'll be having this here equals to this. So now we can make this as our equation 3. Then we solve the equation 3 with any of the equation here that we have here. But we could say that it's obvious we need to solve with that of equation 2. Okay, because they have a similarity there. So we solve the 2 equations. So 2 and equation 3. Now with equation 2 and 3, we can solve them by either adding or subtracting because the variables are the same in terms of the exponents. Okay, so we can now add and subtract. So I will add. So equation 2 plus equation 3. So you'll be having, so you have equation 2 plus 3. Okay, so this should be the root of x plus the root of y equals 19. Then we have the second equation, the third equation, root of x minus the root of y equals 5. And we adding them, so we have plus. So this should be 2 root x equals, because this will be 0. Okay, so this we have 24. Looking for x, so we have root of x equals 12. All right, since we are looking for the value of x, we square both sides, so we have x equals 144. X equals 144. So we do the same thing for the y. Okay, so in solving for the y, we'll be having x, which is 144, put it in equation 1, minus the y equals 95. So we'll be having 144 minus 95 equals y. So we'll be having y equals 49. And you have that for y. So x is 144 and y is 49. Hope you understood. Thank you.